Okay, hello once again. In this video, we're going to go over user-defined data types, Chapter 7 from our Malik textbook. Actually, Chapter 7 is a little bit of a collection of a few random things. So, the only user-defined data type it talks about is numerated types. We'll talk about that, and then we'll talk briefly about namespaces and string types. Interesting, but this should be a relatively shorter video here this time. So as usual, I will post this example code that I'm going to be using. Enumerated types are useful to represent a finite set of discrete values. Okay, so and we can do this ourselves. So what I mean by a finite set of discrete values, for example, if you had something where you need to keep track of the day of the week, you might create a enumerated type, for Sunday, Monday, Tuesday, Wednesday, so on. You can use a set of, in this case, I'm using global name constants of type integer. So I just arbitrarily assign an integer value to each of my constants in the enumerated type, right? So that's what we mean by enumerated type. You do use these all the time in programming, right? I could have used a string, that would have been fine. Okay, so we can do something like that. And then here's an example of a function that's useful for these kinds of enumerated types. So if I need to output the value of this, behind the scenes I'm using an integer, so I might want to convert that to a more human readable string. Okay, so you might have a little utility function like convert day of the week to string, where you give it one of these global constants, so one of the values 0 through 6. And you return back the appropriate string, okay? So that's what we're doing in program. So you might do things like this. So you might declare variables, day of the week, assign a value, and then use that little utility function to convert to a string and display that somewhere on your screen, all right? So let me see if that can, let's build this here and go ahead and run that. So we'll see the output of these two statements, okay? So, as usual, I have a breakpoint down there. So you see this first statement, and it comes out, it works fine. The day of the week is Monday, okay? So, so one of the drawbacks is that there's no check on making certain that we don't put an invalid value into this. So the function is only expecting an integer. So if I assign a value of 7, if you go and look at what the utility function does, we use a standard switch statement to do this. So what happened? So I don't have like a default case here. So none of these cases get selected if I pass in a value that's not 0 through 6. Okay, and at that point, in that case, the default value that I had of unknown gets returned from this function. So you can see that on the second example. Day of the week is unknown. The other thing, to me, the actual real problem of this is that this doesn't give you a good intention of what this code is supposed to be doing. Okay, so I'm not passing in an integer. I'm passing in a particular type of value. So one of the best things the enumerated types do is they make your code more readable. They show the intention of what your code is supposed to do, right? Make it readable to a human being, okay? So let's convert that over to an enumerated type instead of using these named global constants here. So I'm going to comment that region in. So there's just a little hint here for Visual Studio users. There's a lot of useful things on the edit advanced things, including comment and uncommenting the selection. So Control-K-C and Control-K-U to comment and uncomment. So if I want to select that, Control-K-C to comment, and then what I want to do is use this enumerated type here. So Control-K-U, uncomment. So this is the syntax of how I define a enumerated type. Behind the scenes, C++ actually assigns integer values. So it's really representing these as integer values starting at 0, 0, 1, 2, 3, 4, 5, 6, same as what I did before. But now we've got this my own defined data type now. So the day of the week is now a data type, like an integer or a float or a string. Okay, so So we need to fix my code here. So let me go to main and fix it. So first of all, so we're not using integers anymore. We're using our newly defined data type, day of week. Okay. So you see, I mean, that makes it more readable. I mean, this is not an integer. It's something that only holds the day of the week, Sunday through Saturday, right? And let me go with a function then. So, so I want this function, so it's a day of week data type. But yeah, I want it to explicitly say we only accept a day of week coming in as input to this function. And everything else should work the same because I used the same constants here. So by convention, we always use all uppercase for global constants like this. Like these are actually in the global namespace, Sunday, Monday, Tuesday. So, and another thing by convention, user-defined types like classes or like this enumerated type. I like the textbook doesn't do this, but I like these to start with an initial capital letter. Okay, so functions should start with a lowercase letter, and variables should start with a lowercase letter. But user-defined type like classes, structures, enumerated types should start with an initial uppercase letter to show what these are. Okay, so let's see here. I probably did that. So I think I got everything. Let's try that out. See if it compiles. I mean, I see it, but it won't compile right here. So that my second point is, so it's since we know the compiler now knows the day of the week is supposed to be one of these types, not just a regular integer. So it knows when you're trying to assign an illegal value to it. Okay, so we can't do this anymore, right? And likewise, I didn't try this, but I don't think I can even do something like this. I think the compiler will detect that as well, so I can't even send an illegal value as the parameter, so a constant 7 as my parameter to the function either. Same error, so it's detecting that it needs a day of the week data type here, not an integer. Okay, so I just can't do that anymore. I just cannot assign or represent a value that's not a valid day of the week anymore using this variable. Okay. So that's the basics of the day of the week. Let's see, I think that should compile. If I get rid of that one. Yeah. And we'll run it. So it's still running the same, so we still get this day of the week is Monday. Okay. So, notice because in my first output statement, I'm outputting the return value from convert day of the week to string. And if I showed this function too fast or didn't say it, the return type from convert day of the week to string function is a string. And then when you send that to your the cout IO stream, you get the human readable version of the day of the week, Monday. Okay. All right. So one other quick thing for enumerated types, it's often useful in lots of places to actually iterate over. I should have to actually iterate over the. Control K, Control U. To actually iterate over these. This is showing. Unfortunately, iterating over enumerated types is a little bit messier. So this is showing. I mean, I will agree with you. I mean, C++ is not. It's got a lot of warts on it, right? So, and this is one of them. The enumerated type, you can't add and subtract values or increment it directly. I don't know why they didn't add that to the language. So what you do is you kind of just implicitly you can add 1, so it converts the day, whatever the value of the day of the week is, to its integer representation and adds 1 to it. But you can't automatically do that and assign it back in, so you have to do a static cast on this. But you can do it like this. So the textbook shows. So here's iterating over that, and I don't know how those got changed to lowercase here. So so another style thing. So you should be using camel case for variable names and for function names and class names. So convert day of week to string. So every word starts with a capital except for the very first word for variables and function names. Okay, there we go. Let's see if that builds. Build. Oh yeah. Stop debugging. Build it. And succeeded and run. So these outputs have iterated through Sunday, Monday, Tuesday. So you can see the other thing I had on this little loop, I was outputting both, I just sent the day of the week directly to it. So when you do that, when you send one of these day of the week enumerated data types to the I/O stream, it actually just displays the integer value that was assigned to each one of those, okay? So that's why you often need little helper functions like this when you use an enumerated type. So the second thing I do is then I use the helper function to convert to a string so I get the more human readable Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay? So this is the basics of the enumerated type. So congratulations, you've created your very first data type. If you didn't do that before in programming too. So, part of this class is we're learning to create data types, but we're going to get to creating our own more complex ones, lists and queues and things like that. But some of the same things kind of apply here. So. All right. So as I mentioned, this textbook also talked a little bit about namespaces. This doesn't really fit with enumerated types all that much, except on the idea that namespaces are useful to people who are designing new data types, more complex data types. So often what you want to do, if you're defining a new data type or a new library, is you want to define also a namespace and put all the things in the library inside that new namespace. So namespaces are just a way of keeping global different libraries from conflicting at the global level. So if I have two different libraries that want to define a function named ABS for absolute value, they used to conflict in C, and you'd have to, either the library owners would have to make the name different or append their own kind of name to the beginning of all their functions. So the namespace is a way to work around that. Okay, so if you've ever seen the using namespace STD that I usually stick at the front at the top of my class, that's an example of the standard C++ library namespace. It's called STD, right? So the I/O stream and string and lots of other things are defined in the standard global namespace. If you didn't have that using namespace STD, like if you wanted to use I/O stream, you'd have to put STD : all over the place for everything that's in the standard global C++ namespace, right? So the using namespace STD just saves typing. It's basically saying anything that's in the global namespace, I can refer to it without having to explicitly say I want to go to the STD namespace. The chapter gives some examples of how you can find your own namespace. Later on, when we start creating our own abstract data types like linked lists and things, we might want to also use this defining namespace to put those in. And then finally, also quickly, there's a little bit of extra in Chapter 7 about strings. So string is not really a fundamental data type in the C++ language. It's really actually a new high-level object or class in the C++ language. So hopefully you did use these in your Programming 2 class at some point. So you can create strings, variables. In order to use strings, you do have to include the string library somewhere in your file, include string. So you can create a string, and if you want to define a constant, you have to put it in double quotes like you always had to do for a string, and define that in a string. So and you can send those to I/O streams. So if I create string Derek and Harder, and I send those to cout, you'll get hello, my name is Derek Harder. Okay. String data type supports lots of things you can do with them. So it has some operators are overloaded. So the plus operator is overloaded. If you haven't come across the idea of operator overloading our classes, we will be talking about this in Chapter 10 or reviewing it. But this is the same idea as operator overloading. Okay, so the plus operator is overloaded to do string concatenation for string. So if I create a string S and I concatenate a bunch of constant strings in the variable first name and last name, and then output S, we'll see the second line. Hello, my name is Derek John Harder. Right? You can treat strings as arrays, and again, we haven't reviewed arrays. I hope you did see them in programming 2 at least. But in actuality, the open and close bracket is overloaded in order to do array indexing into the string data type. So if I wanted to, for example, assign a different character to index 0 of S, I could do that, and then output S again, and then we'll get Jello. My name is Derek John Harder. And then also there's a lot of member functions that are defined for these string objects, these string data types. So you should look at table 7-1 of our Mallet textbook to see not all of them, but some of the most useful ones. So you can do things like find a substring, the position of a substring. You can do things like insert. So here I insert these characters at position 5, so just before, at position where Derek occurs in the string S. So this string will go before Derek, and then we'll output this, so we'll get this line here. My name is Banana Nana Bo Derek. And substring, so you can get a so this one says starting at index 0, get the first 17 characters from 0 to index 16 of S, and that, so it just outputs the substring. So the first 70 characters of S is hello, my name is space, and then we output the rest of this here, and that's the last line here. Oh, Jello, my name is space. So, all right. So like I said, this chapter is a relatively short one, but those are the main things I wanted to talk about. Hopefully, if you never saw or kind of understood what the use of an enumerated type is, that helps a little bit. So enumerated type it's an important concept. You're actually adding a new data type to the C++ language, and that's powerful. And that's really kind of one of the main things that we're going to be doing in this class, is thinking about adding new abstract data types to the language. All right, so that's it for this video, and we'll see you in the next video.